years, it was believed that the adult brain's pathways could not change. However, now we know that throughout life, the brain has the ability to change its physical structure and function through mental experience alone. This is neuroplasticity. In your brain, 100 billion neurons each fire 5 to 50 electrochemical signals called action potentials every second. Each thought, sensation, or action uses specific neural pathways.
Action potentials travel from the axon of one neuron to the dendrites of another at synapses. Membrane-bound vesicles at axon terminals store neurotransmitters. The protein complexin holds them closed. When an action potential reaches the axon terminal, positive ions let calcium into the cell, activating the protein synaptotagmin, which makes complexin allow the vesicles to release neurotransmitters. The neurotransmitters bind to specific neurotransmitter receptors in the postsynaptic neuron dendrites. High-frequency stimulation of a synapse causes the postsynaptic neuron to bring more neurotransmitter receptors to its surface, amplifying signals it receives from the presynaptic neuron. This is called long-term potentiation. Also, neurons occasionally release neurotransmitters without action potentials in a process called spontaneous release. In 2015, researchers at Massachusetts Institute of Technology discovered that increased frequency of action potentials in a presynaptic neuron not only releases neurotransmitters corresponding to each action potential, but also increases the frequency of spontaneous release well after the stimulation ends. This causes the postsynaptic neuron to signal the presynaptic neuron to activate the enzyme pKa. pKa modifies complexin in the presynaptic neuron so that it allows axon terminal vesicles to release more neurotransmitters. If this occurs at elevated rates, it stimulates the growth of new connections between the neurons, called boutons, making the postsynaptic neuron more responsive to future presynaptic firing. However, long-term depression can also occur, in which low-frequency stimulation of a synapse causes the postsynaptic neuron to remove receptors from its surface, weakening its response. Think of it like this: when you drive on the same path over and over again, ruts form, becoming your default path. However, although it is harder, you can turn your car out of the ruts, driving in a different place. Driving on the new path enough times creates new default ruts.
Similarly, heightened use of synapses strengthens the neural pathways to which they belong, while reduced use weakens them, even leading to them breaking down. Certain mental experiences can also cause synaptogenesis, the creation of new synapses, causing the creation of new neural pathways. How we think and act causes our brains to physically rewire themselves for beneficial or harmful behaviors. Many mental disorders involve loss of activity or overactivity in certain parts of the brain. With the right mental stimulations, neuroplasticity could be harnessed to restore, increase, or decrease such activity. This could help people recover from brain trauma or chronic pain, treat dementia or schizophrenia, and much more. We could give hope to those who used to seem doomed to live with conditions once thought incurable.